This is a 4-wire internal resistance measurement jig for batteries, either coin cells or 18650 cylindrical cells. I was sent this to review for free. If you wanted to purchase it, it would cost you about $18. They haven't paid me for my review, and my opinion remains my own. So inside the box, we have the battery holding jig itself. We also had a random screw just sitting in the box, which I believe came for one of these banana clips. And they provide us with 2 sets of wires. So one set of wires here is thick, so that's probably the current forcing wires. And then one set of wires is thin, which I'm going to suspect is probably the sense measurement wires. And you can see here, basically it has a sliding probe, so you can use these thumb screws to loosen the position of this guy. Maybe. So on the bottom we have one thumb screw that's super easy to turn, and one that was tightened so tightly I need to get a pair of pliers out to start it. So when you loosen those guys, this guy can slide back and forth. Now it's kind of biased to this side because these wires go off to the side, but you can see you can push this all the way forward, and they have these little spring points, contact points here. And so the idea is you can put pretty much any size battery in this rig for testing, and you have to, clamp it into the rig. And when you have it clamped, then you can tighten these guys up and it will hold your battery in place. Now I'm having a little difficulty with the coin cell because it's hard to keep from flipping around inside the rig while I'm clamping it. Alright, so I have a coin cell clamped in there. And then you have connection points here, and you can see on this guy here they have the positive side, and it basically just goes through this circuit board to the connection points on the other side. So this is actually made out of a stack of 3 circuit boards, and these are all made out of pieces of fiberglass circuit board that have been connected and soldered together. And so we have here amp plus and minus, and then the voltage plus and minus connection points. So it is up to you to strip and tin the end of these wires, hook them into the connection points and into the banana plugs if you want to use these wires, and then hook these wires up to your multimeter. So one of these guys had a screw that had fallen out, and so the plastic sheath here had come off. Now if you're not trying to test a coin cell, it's more common you'd be doing something like a AA, AAA 18650 battery, and they have little marks here on the sides that kind of give you a general, put it to about this far apart for this type of a battery. And so you kind of have to hold the battery and this clip here with one hand while you're tightening down the other side. And so now we have this battery held between those spring clips. Now ease of use is not great. So when you loosen this guy up, it can tilt. And so there's nothing in here keeping this from tilting back and forth. And I don't see a good reason for that. I would have really liked to have a slot down the center with a lengthy or set of 2 pegs so that this guy would not tilt around. It would kind of be nice if the whole thing was spring loaded so that you pull it back, you put your battery in, and it spring loads into place and you don't have to tighten anything or loosen anything. I've found these things here, you can tighten them down, and I've actually at some point tightened them down so hard that it was difficult for me to untighten them. And so the whole procedure of putting the battery in the test rig is fiddly. I got it to work. This coin cell was a little harder because the coin cell wanted to flip around a whole bunch. These guys here mostly just stayed in place. But it was a a lot of fiddly work to get this thing in there. So it probably took me 10 to 15 minutes to solder and tin the ends of each of these wires and install everything here. So there's a little bit of assembly required. You'll need a soldering iron to tin the ends of the wire if you want a good connection. And you'll also need a screwdriver that both has a flat head and a cross or Phillips head to put these screws in. So you'll need a little mini screwdriver for that. So how this is set up is we have the current sensing through the big posts here. So, you know, here it's the positive current sensing side goes through there. Now notice there's a little pin that has a spring on it, and that pin is not connected to the positive current flow. It's touching the battery in a slightly different location. So essentially there's a ring that the current flows through, and then this little pin touches inside that ring. Now the exact resistance of each of these paths doesn't really matter because of the 4-wire setup that we're using here. But, you know, so looking at the negative side here, we have connectivity to the outside of the thing, but not this spring post. And so that's the amps. And the amp cables here were 16 gauge wire. And this insulation, I believe, is a kind of a silicone feel insulation. Pretty nice wire and insulation all in all. It conducted heat away really fast. I had to work at it to get it to tin well. You know, so, you know, ideally wouldn't be taking more than about an amp through these wires, but, you know, it's a 16 gauge wire, so it could do a little more than that. And then the sense probes are basically inside here, you know, so these tiny little spring-loaded sense probes are connected to that point there. And as I said, you know, the exact resistance here doesn't really matter because it all cancels out when you're doing the math. And then here's the positive sense probe right on there. Now, to use this, you either need a dedicated 4-wire battery tester, or you need a multimeter to do the voltage readings, and then a current draw that is ideally programmable to do exactly 1 amp. And so you take a voltage sense of your battery when you're drawing current out of it and when you're not drawing current out of it, and you know the difference there at 1 amp of current will tell you the internal resistance of the battery. Alright, so I'm using a battery discharger here, and I wasn't sure how accurate it was, so I'm running it through my amp meter, and it is programmed to do a 1 amp draw, and it's pretty darn close. It is doing 1.024 amps for the draw. So now that I'm confident that it's pretty darn close to 1 amp, I can do my voltage readings. So we are not drawing any current, and the voltage is 4.027. So I've turned on the draw here. It's ramping up to 1 amp. And you can see the voltage is dropping when the draw starts going up there. And so now it's drawing 1 amp, and our voltage here is now 3.96. And it's going down a little bit, probably because we're drawing current out and the capacity is going down slightly. But we'll just say 3.96. Now, after we turn off the draw, it jumps back, and it's, you know, going up and down a little bit, but you can say 4.015-ish. And, you know, number-wise, this is getting pretty close to what it was before. So it went down, we turned off the load, it's going back up. Alright, so we have 2 potential voltage differences here, kind of, you know, from starting to the load and then from the load to ending. And, you know, this number was going up a little bit more, so I think the 0.067 is probably a little closer than the 0.055. But basically, if you take your voltage, you divide it by the amps, you get ohms. And so this 18650 cell under test is basically somewhere between 54 to 65 milliohms of internal resistance. Now obviously hooking up a load and a multimeter separately works fine, but if you have a dedicated battery 4-wire tester, you just plug all 4 of these into that, you push the button, it does all this stuff for you, it does the math for you, and it just spits out the answer for the internal resistance. Now measuring internal resistance on these cells can indicate, if there's a major problem, it'll find that, but it doesn't really give you a good idea of the actual capacity of this cell. It can be useful in differentiating between high amperage cells and long life cells. So some of these are designed to, put out a lot of current really quickly, so they have a low internal resistance. Some of these cells are designed for longer term usage, but they might have higher capacity, and so they might have a slightly higher internal resistance because they're not expecting me putting out a lot of amps. All right, so this guy does a pretty good job of holding your cell, getting all the test leads coming out, connected to banana clips so that you can plug it into whatever device you're using to draw current and measure voltage. It's a little fiddly getting the cell in. This is not a high speed, you're testing 500 cells, you're going to throw a whole bunch of cells into. This is, you have one cell, it takes a little while, you get it in place, you put this exactly where it needs to be and tighten it up. So it works fine. It's a little fiddly to get the cells in and out, so I wouldn't want to be doing lots of cells with this. This is great if you just need something around every so often to measure a cell. I would want something that was spring-loaded, so it'd be much easier to just, put a cell in, take a cell out if I was doing this many times. Also, it's sized so that you can do many different sizes of cells, but if you knew you were only doing one particular size, it'd be nice to have a cradle that would fit the cell exactly so the probe would hit the point exactly, so you wouldn't have to move the up and down thing. So this is a good general purpose, hey, it'll measure any cell, but it's not great for quickly doing a lot of the same cells.